Okay, so let's review transformations. Okay, so the first problem here is asking us to do a lot of stuff, so let's just take it piece by piece, right? So we're starting off with this g of x function here, okay, and it's asking us first to identify and graph the parent function. So we can identify the parent function, remember, by just saying what is the kind of operation that's happening on x if we get rid of all of the like add, subtract, multiply, divide stuff. So if I get rid of this 3 and this 2 and this minus 1, all I'm left with is the x and the squared, and that's the parent function, right? Y equals x squared. Okay. So if I were to ask you to graph this, remember what we can do is just pick values to plug into x squared, and it's always nice to include a couple of negatives if possible and a couple of positives and all that. So I'm going to make a little t-chart, and we'll do it below the graph so we don't use up any of our space here. So I'm going to say, okay, if I make an xy table, and I'm just going to write here that we're actually going to be plugging into x squared, okay? And so if I plug in the numbers -2, -1, 0, 1, and 2, right, I'll get a couple of negatives. 0 is always a good number to try to include, and then 1 and 2, okay? So if I plug these in and square them, I'm going to end up with a 4, a 1, a 0, a 1, and a 2, right? That's the x values all squared, okay? So if I graph that, here's what I end up with. I end up with -2 up to 3, 4. Okay. I end up with -1 up to 1, 0 to 0, 1 to 1, and 2 to 4. Okay. And this is a nice U-shaped graph, which in an Algebra 1 class you should have seen as referred to as a parabola. So this is a parabola. Okay. This is the parent function. All squared functions look like this. Okay. So part A is now complete. We've identified the parent function as x squared. We graphed it. It looks like a parabola whose, we call this the vertex. The bottom point here is at 0, 0. Okay? So if I asked you to describe the transformations, basically how did we turn this parabola into this one, just describing it with words, here's what we'd say. Okay? I have an a value, okay, which is equal to 3. Okay? And that a value's job is going to be to do vertical work, right? A value always affects the y coordinate, which is vertical. Okay, so it is a vertical. It's going to be a stretch. Okay, and it's a stretch because this number is bigger than 1, right? So things that are bigger than 1 stretch, things that are fractions and decimals will cause it to compress. Okay, so a vertical stretch, and we write by a factor of 3. Okay, okay. And the reason we're saying a factor of 3 instead of just saying vertical stretch by 3 is because we're actually going to multiply all of our distances by 3. And that's what the word factor means, is to multiply. Okay, so that's one transformation. Okay, we don't have a b value. B would typically be multiplying inside, and we don't have anything. So we're going to move on to c. Okay, so this says +2, and just to remind you that the standard form for any of these functions is x minus c. So that means that we plugged in a -2 to make x minus c look like x plus 2, right? And if you want to see that off to the side, right, if my equation looked like this, and I get rid of c, okay, and in its place I plug in -2, okay, what you end up with is, oh, excuse my slow computer, right? Let's try that one more time. -2, right? You can see I get x minus -2, which is really plus, right? So that's why our equation looks like plus, okay? So this thing's job is to move it to the left, okay? And it's going to move it to the left by 2 units. Okay, so left by 2 units. So let me grab my pen again. It disappeared. There we go. It caught up with me. Okay. So left by 2. And then I have a d value, one more. So d is going to cause it to go -1 down by 1. Okay. So that's how I'm going to describe the transformations, down 1 unit. Okay. Okay, so now it's asking me to sketch g of x, right? So there's a couple things I can do here. Okay, one thing is I can transform. I can use my a, c, and d to transform this parent function table. So let's see what that looks like. So I'm going to make another little xy table over here for my newly transformed function. Okay, so if you remember what we said that if you kind of remember this little table that says x and y, right, very similar to our t-chart here. On the x side of the table, we are going to affect the be affected by b and c, and on the y side of the table, we're going to be affected by a and d. Okay, and the way that these things affect x and y are by multiplication and addition, right? B is multiply, c is addition, and then on the other side, same thing. Okay. So now we're going to say, okay, if I got to transform this table into this table, right, we're going to say multiply by b. Well, we don't have one, so who cares, right? Add the c value to the x coordinate, and our c value is -2. So if I add that to all of these x coordinates, here's what I end up with. -4, -3, -2. Okay, and then if I add -2 to 1 and 2, I end up with -1 and 0. Okay, so it kind of shifts everything to the left by 2, just like this says. Okay, and then the y side is going to be affected two ways. One is going to be the factor of 3, so I'm going to multiply everything by 3. So this would be, I'm just going to do a little interim step here. It's going to turn into 12. It's going to turn into 3. Okay, it's going to turn into 0, right? 0 times 3 is still 0. Okay, it's going to turn into 3 again, and it's going to turn into 12 again. Right? This first one's a very poorly drawn 12. Okay, so now that's my A transformation. I multiplied everything by A, and now I'm going to add D, right? So add a -1, and that's what's going to come over here. So this is going to become an 11. Okay, this one's going to become a 2. Okay, and then I'm going to get a -1. I'll get another 2 and another 11. Okay, this is because these are symmetrical. Okay, so if I graph this now, I'm going to say -4. 1, 2, 3, 4. It's going to go all the way up to 11, which is just off the graph up here. Right, -3 is going to go up to 2. Okay, -2 is going to go up to, or down to -1. Okay, and then -1 will also go up to 2, and 0 will go up to 11 again, right? So if you notice, I'm also getting this nice U-shaped parabola. There it is, okay? But it meets all of this transformation information. We shifted everything to the left by 2, we shifted everything down by 1, we stretched all the points out so it looks a little skinnier, okay? So I did all of that. That's the kind of letter C, right? And so the only thing I have left to do now is to describe the domain and range, and that's what this graph's going to help me with, right? G of x is kind of the new red graph that I just drew. So I'm going to say, okay, well, it looks like this thing is kind of slowly going up and to the left, and it's also slowly going up and to the right. So that means that it's going to the left forever and it's going to the right forever. So I'm going to say that the domain is everything, right? There's no endpoints as I go from left to right. All right, so I'm going to say everything from -infinity to infinity. Okay. The range, however, does stop, right? This thing goes down, 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 and it gets to -1, and then it turns around and it goes back up, right? So I'm going to say in this case that the range starts as low as -1, square bracket, so I include -1, and it's going to go up to infinity, okay? So this would be my domain and range, okay? So every single problem is just going to work like this. So when we look at the next one, same basic idea. Okay, we do have a b value here though, so we have to be careful. All right, so I'm going to start off with this one by kind of pulling this information off to the side and saying, we'll do it over here because we got some space. -x minus 2. Remember, we always want it to be a parentheses, an open parentheses right before the x if there's anything else there, right? So I'm going to say this is really the same as negative parentheses x plus 2. Right? And that makes a difference because you can see that affects the c value, okay? So if I start off by identifying the parent function, right? This one, again, if I get rid of the minus sign here, the -2 and the +3, all I'm left with is the square root of x, okay? If I want to graph the square root of x, we have to be careful because there are values that I am not allowed to plug in to a radical, and those numbers are negatives, right? So when I start this list, I'm not going to start at -2, because I can't square root -2 and put it on a graph. I'm going to start at 0, okay? And then I'm going to put down 1, and then I'm going to think about putting down 2 and then realize if I square root 2 on a unit graph like this, I'm going to get decimals and it's going to be hard to graph. So I'm going to skip 2, I'm going to skip 3 for the same reason, the square root of 3 is a decimal, and I'm going to go to 4. I'm going to skip 5, 6, 7, and 8 because all the square root of all of those is also nothing nice, right? And then I'm going to put down a 9, right? Square root of 9 is 3. So now if I square root each of these, I get 0, 1, 2, and 3, right? So I was just picky about which domain values I'm going to choose to graph. That doesn't mean that the other ones don't exist. They're just not nice to graph, right? So I'm going to start off at 0, 0, and then 1, 1, 4, 2, okay, and 9, 3. And we get this, I call it the shooting star, right? It starts off at 0, 0, and it kind of goes up and to the right and travels forever that way, okay? So that's our graph and our parent function, okay? If I ask you to describe transformations, again, I got 3 values. I have a b value that is -1, Okay, I have a c value that is -2, and I have a d value that is 3, right? So if I identify what each of these things do, okay, the -1, if I flip over 1, if I take 1 over 1 and I flip it over, I still get 1 over 1. Okay, so this is the weird special case where nothing's going to change. Okay, because the value of b when I flip it over is still 1, that means it's not going to do any stretching or compressing. 1 is neutral. Okay, but the negative sign is going to make a change. It's going to cause it to reflect, okay, over, okay, and b's job is to affect the x coordinates. So all of these positive x coordinates are going to be negative x coordinates, so it's going to go over the y-axis, right? In order to get to that other side of the graph and go this way instead, it's got to go over the y-axis, which is this one, okay? The c value we've talked about, that's just to the left by 2, okay? And then the d value is going to cause it to go up by 3. So then if I say let's sketch g of x, okay, again, I'm going to make my little xy table, okay, and we're going to transform these 4 x values by multiplying by the reciprocal of -1, which just happens to also be -1. So if I take all of these values and I multiply them by -1, it just switches their sign, so I end up with 0, -1, -4, -9, okay? And then I also need to, I'm just going to make a whole new table for this, right? I need to change by adding the c value, so adding -2 to all of these numbers, right? So that's going to make my new table -2, -3, -6, and -11. Okay, so that's my new, if after I did b by multiplying and then c by adding, I end up here. Okay, and then my d values, if I go up by 3, it's just add 3. So I'm going to skip this chart because it's going to end up here anyway. If I add 3 to all of these numbers, I end up with 3, 4, 5, and 6. Okay, so that's my add 3. Okay, so if I graph this thing now, -2, okay, 1, 2, it's going to go up to 3. Okay. -3 will go up to 4. -6, 1, 2, 3, 4, 5, 6 will go up to 5, which is right here. Okay, and then -11 is a little bit off the graph over here, but that's going to go up to 7. Or I'm sorry, up to 6. Okay, so now my graph, if you notice, I'm not going to start down at 0, 0. This 0, 0 point is the one that kind of moved over here. So I'm going to start here and kind of head this way. Okay, and you notice, again, it's still that same shooting star, but it reflected and it moved over to the left and a little bit up. Okay, so here's what's really important. Now that I see this graph, as ugly as my drawing is, I can talk about domain and range, right? And it looks like this one starts at -2 and heads to the left forever, right? And so I'm going to say that is, remember, we always kind of start on the left-hand side. Negative infinity is over here, and it keeps going until it gets to -2. So I'm going to say the domain is negative infinity, and it'll get to -2 and it'll stop. I want to include -2, so square bracket. Infinity never gets its up square bracket. We can't include infinity. Okay, my range, it looks like it starts up here at 3 and then goes slowly up forever. You can see that my table of values starts at 3 and goes 3, 4, 5, 6. So it's going to keep going as I make these numbers more negative. These will start to go up. So it looks like this is going to go from +3. Okay, and it's going to go up forever, so that's going to go to infinity. Okay, so this one does have a restriction on both the domain and the range. Okay, one little thing I want to point out, and hopefully you start to pick this up. If you notice, your c and your d values are -2 and 3, and if I look at the domain, which remember b and c affect the domain, they affect the x coordinates, it stops at -2. D affects the y side of the graph, which is the range, right? And that's got a 3 in it, right? So it's not a coincidence that your parent functions generally have a 0, 0 in them, right? And then the domain and the range are affected by c and d a lot, right? Where I'm going to see those numbers show up a lot of times in your domain and range. So that's not a coincidence if you happen to notice that. Okay, so we're going to zoom through 3 pretty fast because this is the third now, and I think we still have a fourth as well. Right, so here's your third one. Right, so we're going to say our parent function is just the absolute value of x. Okay, if I graph this, okay, I'll just let you do the plug-in. You're going to end up with 1, 1, 2, 2. Right, it's going to look something like this. Okay. And I'll generate a table because we're going to use it in a little bit. Okay, so if I take -2 and I plug it into an absolute value of x, I get 2, right? And then the same thing's going to happen for the rest of them. Remember, it just makes it positive. Essentially, we're talking about distances, which are always positive, right? So here is my parent function graph, which again, I'll just note that this is the parent function right here, okay? So if I want to describe the transformations, I have an a value, which is -1/2, and I have a c value, which is -3, right? So we're going to say that a now does two things. It is going to do a reflection, okay? And it's going to do it over the y-axis, I'm sorry, the x-axis, okay? It's going to go from top to bottom. It's a vertical reflection, okay? It's also going to vertically, okay, compress, okay, by a factor of 1/2, okay? I don't want to get into my graph too much. Okay, there we go, okay? So vertically, and again, I'm using the word compress because 1/2 is a fraction or a decimal, so that means that all of the distances are going to get vertically smaller, okay? And then the -3 is just going to go to the left by 3, okay? So the nice thing is with my XY table, I can do each of them one on the X side, right? C does the X side and A does the Y side. So I'm going to just be able to do it in one chart, right? So if I take all of my BCADs and I say, let's add -3 to all of the X's, that's going to make it -5, -4, -3, -2, and -1, okay? And then my y side, I'm going to multiply all of those by -1/2, right? So if I do that, I'm going to end up with -1. I'm going to end up with -1/2, 0, -1/2 again, and -1 again, right? So that's going to be my transformed chart that represents g of x. So I can graph this now, right? -5 goes down to -1. Okay, -4 goes down to -1/2, which is like right here. Okay, and then -3 is at 0. And -2 goes back down to -1/2, and -1 goes down to -1. So if you notice, like it's reflecting, right? This thing is now, okay, upside down. It's still a V shape. All absolute values are a V shape, but it reflected, so it's opening down now, and the arrows are pointing down, and the compression caused the graph to look a little bit wider, right? So now if I talk about domain and range, hey, the domain for this one is everything. It's going to the left and to the right forever, okay? But the range is going to be significantly changed, right? So the original domain and range was from 0 and everything up, right? But because I did a reflection, it's going to actually be from -infinity up to 0, and it's going to stop, okay? And if you notice, again, just to point this out, there's no d value in this one. D would have changed that 0 up and down, but since there was no up or down, it stayed at 0. But the reflection did make it, instead of going from 0 to infinity, now it's going from -infinity up to 0, okay? And this should be a rounded bracket, okay? All right, last one, okay? So parent function for a cubic, right? If I see cube show up, is x cubed, okay? I again have 3 transformations. I have an a value, which is -1. I have no b value. I have a c value, which is -2. And I have a d value, which is -1 as well, okay? So a is going to do a reflection, right? Just like the -1/2 in the last one. Reflection over x, okay? My c value is going to cause it to go to the left by 2, okay? And my d value is going to cause it to go down by 1. Okay? All right, so if I sketch the parent function, here's what I'm going to end up with. Again, I'll do an xy, okay? And I'm going to use the same values. You might have to think about cubic a little bit more because we don't see those as much, but there's really no problem with cubing things. I can multiply -2 by itself as many times as I want without any issue. So I can start, I'm going to do that same -2, -1, 0, 1, 2, right? Again, it kind of gives you a nice like variety of values, right? So -2 cubed is -2 times -2, which is 4. 4 times -2 is -8, right? -1 cubed is -1, 0, 1, and 8, right? So here's what the parent function looks like for cubics. -2 is going to go down to -8. -1, -1, 0, 1, 1, and then 2 goes up to positive 8, okay? So it's kind of like if you think about a parabola being right here, we're taking this end of the parabola and we're turning it down instead, and that's what a cubic looks like, right? It's going to go like this, turn sideways, and then turn up again, right? And we get this graph, okay? So this is a cubic parent function, okay? So if I were to ask you then to sketch g of x, or again, let's do our table transformations, okay? I only have one x transformation, and that is to add -2 to all of my x coordinates because it's going to the left 2 units, right? So if I do this, okay, I'm going to say -4, -3, -2, 0, and 1, right? If I added -2 to all of these, that's where I would end up, okay? -4, -3. I'm just double checking my work here. Oh, I knew there was something wrong. That's what I was trying to figure out. This is -1 and 0. I skipped something. Okay. All right, so that looks better. Okay. So now we have A transformations, and there's going to be 2 transformations that happen on the y coordinate, right? We have to do A and D, right? So if I multiply all of my y coordinates by -1, it's just going to switch their signs. This is going to be 8, 1, 0, -1, -8, right? That would be my multiplying by A. And then if I take all of those numbers and I add -1, my 8 is going to become 7, okay? My 1 is going to become 0, right? My 0 is going to become -1. The -1 that's going to show up after A is going to then be added with another -1 and make -2, right? And then this -8 will become -9, right? So that's my kind of new graph, right? And I can sketch this, right? So -4 is going to go down to, or up to 7, which is here, okay? I have -3, which is going to be at 0, okay? I have -2, -1, okay, and then -1, -2, okay, and then 0 is going to be all the way down here at -9. Oop, let's try that again. Okay, -9, which is this one right here. Okay, all right. So if I sketch this again, it's going to be like down until I hit these points, turn sideways, go through those 3 that are kind of like straight, and then turn again. And it'll look like this, okay? So if you notice, there was a reflection instead of the left side pointing down, now the left side's pointing up, right? And there was a shift to the left and a shift down, right? This point here is easy to track. You can see that it's now here, right? So it looks like it met all of our reflections, right? So if I talk about domain and range here, here's the fun thing about cubics. The domain is everything. This goes from -infinity up to infinity. It does slowly go to the left and right forever. Right? The range is also everything. This goes down forever, and it goes up forever. Okay? So there really was no change to the domain and range here, because if the original graph was everything, right, and this one's also everything, right, we really can't take anything away from that. Okay? All right, so a little bit easier going forward. Those are the really long ones, so we should be able to zoom through this now. Okay, so standard form for this, for generally speaking, is going to look like this. We're going to have A, B, parentheses x minus c, right? And then close that off plus d, right? And if you remember, we kind of had a little f sitting out in front of this to remember, like, be like whatever function, you know, this turns out to be, the f will go away, right? So this one's actually already in standard form. There's no problem with this. So I'm just going to bring this down and say -2x cubed plus 3, right? The d value's at the end, the a value's at the beginning. There's no inside, so I don't have to worry about any of that, right? So if I talk about transformations, here are the 3 transformations, okay? A is -2, okay? So that's going to cause a reflection over the x-axis, okay? That's what the negative does. And then the 2 causes a vertical stretch. And remember, it's stretched because 2 is bigger than our neutral value of 1, and it's by a factor of 2. Which is longer to write than it is to say. Okay, and then I have a d value at the end. This is just going to cause it to go up by 3 units. So d is equal to 3. Okay, that's up 3 units. Okay, and so those would be our transformations. Okay, so problem number 6, very similar. Okay, this one is not in standard form, and the reason it's not in standard form is because the inside does not look like b parentheses x minus c. So the only thing I need to change about this, I'm going to leave the -3 alone. Okay, I'm going to then take this 3 out, okay, and I'm going to kind of just to differentiate the parentheses. Okay, they kind of look like this. So I took this 3 out, and then I'm going to say, okay, on the inside, if I take the 3 away from x, I'm left with just x, okay, minus. And then what I basically did to get this 3x to just become x is I divided by 3. That's what really GCF does to the inside components. So I'm going to take this 4 and also divide it by 3, and it becomes the fraction 4 over 3, okay? And that's going to be plus 1, right? So this is my standard form with the b parentheses x minus c all set up, okay? And then the transformations, just for the sake of time, I'm just going to type them instead of writing them all out. So let's do this, okay? Okay, I can type better than I can write. So I'm going to have an a value, which is equal to -3, okay? And that's going to cause the following things to happen, right? We're going to end up with a reflection over the x-axis, okay? And we're also going to end up with, let me make this a little smaller so I got some space. Let me make it like a 20. Okay, there we go. Okay, a reflection over the x-axis, and we're also going to end up with a vertical stretch by a factor of 3. Okay, so that's my two A transformations. Okay, B is, you have to be careful. B is 3. Okay, but we're going to take that B value and we're going to flip it over and make it 1/3. Okay, whenever we're considering what B does, we always take the reciprocal. Okay, so this is going to cause because it's 1/3, a horizontal compression by a factor of 1/3. Okay, so again, if you notice, A's value is to do vertical work. B's value is to do horizontal work. Okay, I have a C value which is equal to positive 4/3, and that's going to cause a right shift. Okay, which I'm going to use the vocabulary word. It's a translate. Okay, right translate by 4/3, okay, of a unit. Okay, so the 1 1/3 unit. Okay, and I have a D value which is equal to 1, and that's going to cause the whole graph to shift up by 1. Okay, so that's going to be our 5 different transformations. Okay, problem number 7. Okay, not in standard form, so I'm going to have to do a little writing for a second because I can't type square roots. Okay, so I have the same issue here where the inside of this square root does not look correct. So when I fix it, I'm going to say this really should be 2 parentheses x plus 2. Okay, and then the plus 2 on the outside is fine. Okay, so that's going to be our standard form. Okay, let me make this a 20 again. That seemed to work. Okay, I have no A value here. I do have a B value which is equal to 2. Okay, and again, I'm going to flip that over and make it a 1/2. Okay, and so what that's going to cause is a horizontal. Okay, horizontal. Okay, compression by a factor of 1/2. Okay. I have a C value, which, be careful, remember, is -2, okay, and that's going to cause my graph to go to the left by 2, to the left by 2, okay, and then I have a D value, which is equal to +2, and that's going to cause my graph to go up by 2 units, okay. So those would be your transformations on the parent function, which was the square root of x, okay. All right, problem number 8. Same issue here, right? I have this inside of the absolute value bars, right? And the inside is currently not in B parentheses x minus c, so I'm just going to fix that. It's going to be 2 parentheses x minus 1, okay, minus 2, okay? So we'll do our transformations. Okay, let's say that, okay, 20 units, okay, and then we can start typing. So I have an A value, which is equal to -1. That's that negative that's sitting on the outside of the absolute value. Okay, that's going to cause a reflection over the x-axis, and that's it. Remember, 1's neutral, so no stretches or compresses. I have a B value which is equal to 2. I'm going to flip that over and make it 1/2. Okay, and that's just going to cause a horizontal compression. I can't spell horizontal. Horizontal. There we go. Compression by a factor of 1/2. Okay. I have a C value which is equal to +1. Okay, and that's going to cause the graph to go to the right by 1 unit. Okay, and I have a D value which is equal to -2, and that's going to cause the graph to go down by 2 units. Okay, and so I have 4 transformations. A, B, C, and D all do show up. Okay. All right, problem number 9, I believe, is our last problem. All right, let's do this. Okay, so this is the problem where we're going to actually do something similar that we did on those first 4, except we're just going to take 2 comma 4, 1 point, okay, and we're going to transform just this 1 point. Okay, I'm not going to even put it on the graph. We don't need to do that part. Okay, so it says find a point on the graph of this thing. Okay, so what this thing is a transformation of f of x. So that means if 2, 4 is on f of x, that if I transform 2, 4, right, I'm going to end up with a point that is on this thing. So this question is just asking us to transform 2, 4 using a b value of -1 and a d value of 6. That's what this thing is. Okay, so I'm going to start off with my b value, right? If you remember, b affects the x coordinate using multiplication. Okay, and if I flip over 1, just kind of let's see, you can see this. -1 over 1, if I flip it over, right, is still 1 over -1, and that's not any different, right? -1 over 1 is -1, and 1 over -1 is also -1, right? So the flipped over version just happens to be the same thing. So if I multiply by that, this becomes a -2. Okay, and then my d value just says add d to the y coordinate, so that's going to become a 10. So -2 comma 10 is your final answer. Okay, same thing's going to happen with number 2. I'm going to start off at that same 2 comma 4. Right, this is a different transformation on this f of x. Right, it looks like I have an a value and I have a c value, which is really -1. So I'm going to start off with c, because remember, b, c, a, d. Right, I don't have a b. Next thing is c. All right, so I'm going to add -1 to my x coordinate. There it is. Okay, and then I'm going to multiply by a. Okay, so that looks like it's going to be -12, right? 1, -12. Okay, last one, we made it. Okay, 2 comma 4. Okay, we're going to do a c transformation of 3 and a d transformation of -2. C is going to be added to my x coordinate, so that's going to be 5. Okay, and D, okay, is going to be added to my y value, and that's going to make that a +2. So 5 comma 2, and that is all of transformation. So if you can do everything that's on here, you are good to go. In fact, this is probably a little overkill, right? You definitely won't see the graphing section, but you'll still have to do like domain and range and stuff, right? So hopefully that will answer your questions. If you have any, please let me know.